Welcome back to Python scripting for GIS applications. This is a class at the University of Alaska Fairbanks, and it is spring semester 2013. From last time, your assignment was to use the zonal statistics as table tool to determine the majority of pixel values inside each polygon. And the problem is these polygons are overlapping, so we're going to have to do it by polygon in a loop. So the first thing I'm going to do is specify my output workspace to be a geodatabase container. And then I'll specify my input raster. And that's going to be equal to this burn raster. And then my polygon feature class is my overlapping polygons feature class. And then we need to determine how many polygons are in this polygon feature class. So we'll say poly count is going to be equal to arcpy.getCount for my poly feature class. So that would return a result object. And what we could do is turn that into a string using the Python string function, and then convert that string into an integer using the Python integer function. So how many polygons are in that feature class? There's 10 polygons in that feature class. Okay, so the next step would be to load the spatial analyst extension. So if it's available, we check it out. And if it's not, we'll just put a message, error could not load our spatial analyst extension. So now we've got the spatial analyst extension loaded, and we can have access to all the tools in the spatial analyst toolbox. And then we'll import those tools, and that way we don't have to always say arcpy.sa.spatial analyst geoprocessing tool. We could simply type in the name of the tool we want to use. Okay, so what we're going to do is we'll make a feature layer for each polygon, and we don't necessarily need to see those. So we'll set our add outputs to maps to be equal to false. And then we'll make a feature layer for each of the polygons in our polygon feature class. So the first thing we'll do is make an empty list that's going to contain our zonal statistics tables. So that will be an empty list. And then we'll loop through. So for I in the range from 0 to the number of polygons we have, we'll make a query. So feature ID equals 0, feature ID equals 1, feature ID equals 2, etc. And then we'll create a temporary layer. So layer 0, layer 1, layer 2, etc. And then make feature layer from our query. And the output from that make feature layer tool will be a layer in ArcMap that's just going to be this poly layer object. So for example, it'll be layer 0, layer 1, layer 2, and so forth. So we'll have individual polygons in each of these layers. And then we'll make a string variable for our output table. So that's going to be majority 0, majority 1, majority 2, etc. And then we can run the zonal statistics tool. So basically, zonal statistics as table, take our poly layer, which would be one individual polygon, and use its ID as the zone. And then with that polygon, find all the pixels from in raster, get the majority of those pixel values, and put it in this output table. And then what we want to do is append our list of tables. So we made this empty list of tables. .append, and then we'll append our out table to that empty list of tables. Okay, so we'll run this loop. So it looped through every polygon that was created from this ArcPy make feature layer. So let's see what tables were produced. So now we've got a list of tables, majority 0, majority 1, majority 2, all the way up to the total number of polygons in our input feature class. So then we could simply use the ArcPy merge tool to merge the tables together. So it's ArcPy merge management, the name of our list of tables, and then whatever we want to call our final output table. So I'll just call this merged tables. And we're outputting to a geodatabase, so I don't need a .dbf extension. And then we can look at that final result, the merged table. So the final result is for these 10 polygons, each of them had a majority of burned pixels in that polygon buffer. And the count would be the number of valid pixels inside each polygon. So for example, we could look at polygon number 6 and zoom to selected layer, and so polygon number 6 has quite a few pixels that were no data. So that's why in the merged table, polygon number 6 had a lower count compared to the other buffers. The same thing with polygon number 7. It was sort of on the edge, so it had some no data pixels. Okay, in this session, I want to teach you how to access raster properties. So I'm going to set my workspace to a folder, and this folder contains mean monthly temperature rasters. So let's say I want to get a list of the rasters from June, so I can make some variable, and then use the arcpy.listRasters function. So then I could use a wildcard, so asterisk June asterisk. So that should return a list of all the rasters in this current workspace that have June in the raster name. So then if I look at my list of rasters, I've got a list of rasters, they all have June in it. So I could say, well, what's the number of rasters in that list? So I can use the Python function length. So there's 10 rasters in that list. Okay, so how do we access properties of rasters? Okay, assuming you've loaded the Spatial Analyst extension, like we did in our previous video session. So if we have the Spatial Analyst extension loaded, we could basically specify any of these text strings is actually a raster. So for example, we could say, well, let's extract a string from this list of strings. So let's just get the first item in this list, and then make sure that this is just a string. So it is a Unicode string. So now we could basically tell the Spatial Analyst extension that this is actually a raster. So we would say my raster, whatever you want to call it, is equal to raster, and then the name of the raster. So now we've got a raster object. I called it my raster, and we could ask about properties of that raster object. So for example, my raster dot catalog path. What's the catalog path for this raster? So that's the catalog path for that raster. Okay, how many rows and columns does this raster have? So the number of columns will be the width. So there's 85 columns for that raster. And the number of rows will be the height. So there's 55 rows in this raster. Okay, how many pixels are inside, or how many values are inside each pixel? So the number of values inside each pixel is the bands, or the number of bands. So we want to know the band count for this raster. So in this case, since it's a temperature raster, there's one temperature value inside each pixel. And then does the raster have a raster attribute table? So that's has raster attribute table. So RAT, does it have a raster attribute table? In this case, there is no raster attribute table. So raster attribute tables are built only if the raster has integer values for pixel values. So the question is, what is the type of pixel value inside every pixel? Is it integer? Is it floating point, etc.? So my raster.pixel type will tell us what type of values are inside every pixel. So in this case, there are floating point values inside every pixel, so they're 32-bit floating point values. So if you've got a floating point raster, it will not have a raster attribute table. If you have an integer raster, it can have a raster attribute table. And then how about some descriptive statistics about our raster? So my raster dot So some descriptive statistics that we could specify could be maximum, mean, minimum, standard deviation. So what's the mean temperature value for this raster? So the mean temperature value is about 15 degrees centigrade. Okay, so if we try to run the ArcPy build raster attribute table, we get an error message. And the reason why we get an error message is only integer raster dataset are valid input for this tool. So your assignment is to write an ArcPy script that builds a raster attribute table, but it builds a raster attribute table for a raster only if the pixel type is integer. And so basically you'll start your script getting a list of rasters in some workspace, and then for any raster in that workspace, if it's an integer raster, check whether it has a raster attribute table, and if it doesn't have a raster attribute table, build the raster attribute table. And I'll go over a solution to that script at the beginning of our next video.